In this tutorial, we will be talking about discrete random variables. We'll be talking about three main things. Firstly, what is a random variable? Secondly, what is discrete data? And thirdly, what is the correct notation that you should use when working with discrete random variables? First of all, what is a random variable? A random variable is one whose value cannot be predicted, but it's determined by the outcome of an experiment. Let's look at an example to illustrate what we're saying here. A die is rolled a number of times and the numbers appearing uppermost are recorded. The possible outcomes could vary each time we roll the die. We know that the outcomes we could expect are 1, 2, 3, 4, 5 or 6. Each time I roll the die, we could get a different outcome. On our first roll, we might get a 2. On our second roll, we might get a 4. On our third roll, we might get a 6. On our fourth roll, we might get a 2 again. So each time we roll the die, we get a variable, a value which could vary with each roll. Because the outcomes could vary with each roll, the outcome of each roll is known as a random variable. So what is discrete data? Discrete data is special data that can only take on a separate or distinct value. More specifically, it's countable data. It generally deals with countable numbers or sizes. To give you some examples of discrete data, the first one is the number of children in a family. This is an example of discrete data because to collect this data and find out the number of children in a family, I have to count to get the final number. Any data which is collected by counting is discrete data. Also, when I talk about the number of children in a family, the values I could come up with are separate and distinct values. There could be 1 child, or 2 children, or 3 children, or 4 children. But the number of children in the family can only take on those separate and distinct values. I can't have 4.5 children in a family, or 4.1 children in a family. It either has to be 4 children or 5 children, and nothing in between. Some other examples of discrete data are the number of goals scored in a netball game. Again, to collect this data, I would have to count the number of goals. So this is countable data. Secondly, the number of goals in a netball game has to be separate, distinct whole values. 10 goals, 20 goals, 30 goals, but not anything like 20.5 goals or 30.2 goals. Another example is shoe or shirt sizes. Again, this data has to have separate and distinct values. For example, if I'm talking about shoe size, I can only take sizes such as 6 or 6.5 or 7 or 8 or 8.5. Nothing in between. The values are separate and distinct values. And lastly, the number of books in a library. Again, to collect this data, I have to count. All of these examples are examples of discrete data because to collect the data, I would have to count it. Lastly, what is the correct notation that you should use when working with discrete random variables? Well, first of all, random variables are always expressed as capital letters. The most common capital letters we use are X, y and z. The value that the random variable can take is represented by a lowercase letter. Again, x, y and z, but this time lowercase x, lowercase y and lowercase z. An example of how we would write it would be something like this. This reads, the probability that x takes on the value of 4 is equal to 0.29. Here, the capital X stands for the random variable, which is usually defined in the question, and here is the numerical value that the distinct random variable takes. Here is its probability. PR is always notation for probability. So once again, X is the numerical value assigned to a particular desired outcome or variable of interest. A number is assigned to each outcome in the sample space. These values are said to be discrete because they can only take on countable values. We will illustrate this in our next tutorial when we look at a number of examples and turn them into discrete probability distributions. Thank you for listening.